in our last lesson, we have done the equation of a line in 2 dimensions. And in this lesson, we are going to extend that equation of a line in 2 dimensions to 3 dimensions. So first thing, we want to do some review of the equation of lines in 2 dimensions first. Then after that, we are going to extend it to 3 dimensions. So this is what we have done in our last lesson. So r equals r0 plus td. So r0 is just 1 point on the line. So this is r0 is not 1 point on the line. Then the direction vector is d. So r0 plus t times d will give you the new vectors. This is a xy coordinates for the point on this line. So, and if we change the t, you will find all the points on the line. So that's the reason this is by using 1 point and also the direction vector, we could generate all the points on this line. So r0 plus t times d, we could write it as d1, d2, x direction, y direction. So then once we write the x component, y component out, we have the parametric equation. So r0, we write it as x0, y0. The x component is just x0 plus t times d1. That is the first part. And symmetric equation is just x solve for t. X minus x0 divided by d1 equals y minus y0 divided by d2. Or you could just remember x minus the first point, x direction, y minus first point, y direction, then all over the direction vector, x direction, y direction. And the Cartesian equation in standard form, we could just cross multiply, then simplify, we could have this one. So now we are going to practice find the normal. Normal means it's just perpendicular to the line. So this is a normal. If this is a first line one, okay. So in example 1, we want to find the normal to each of them, okay, and write it in the equation this form, Cartesian form. So y equals negative 4x plus 1, then with the same y-intercept. So we are going to see the slope of this one is mx. So this is our slope. We write it as a fraction. So integer divided by 1, giving you the same thing. So we change it to fraction. So this is rise, this is run. And we know the normal perpendicular one will be the negative reciprocal. So negative becomes positive. Then reciprocal means flip over. So opposite flip over. So it's 1/4. Then the point is same y-intercept, means the b value is same. So we have the slope, we have the b, we could write it y equals mx plus b, 1/4x plus 1. So this is our equation of the normal. And we want to write it in this form, so we want everything to be one side. We want the number at front of x is positive integer. So this is positive already. We want to move the y to other side to make sure the number at front of x is positive. Then we don't want to see the fraction at front of x. How to get rid of it? We could just times 4 to each term. So 4 times 0, so it's just, this is equation, we times 4 times denominator to each side, each term. Then we are going to have 4 times 0 give us 0, quarter times 4, you could think numerator times numerator, denominator times denominator. So 1 times 4 divided by 4 times 1 give us 1. So it's just x. Minus 4 times y is 4y. 1 times 4 is 4. Then this is our Cartesian equation for the normal to this equation line. Then question B. So question B, this is 1 point. This is our direction. So our direction is 3, 7. So this is our run. This is our rise. And the perpendicular one will be the negative flip. So flip these two. And one of it need to be negative. We could just put any of it as negative. So negative 7, 3, then pass through this point. Then we could write it as a symmetric equation because we want to cross multiply. So x minus x component of that point, I will copy this one first, d1 equals y minus y0 divided by d2, and be careful, this d we are going to use a normal to do the calculation. So x minus x0 is 1 divided by d1 equals y minus y0 is negative 2 minus negative 2 divided by 3. Then cross multiply, we are going to have 3 times x minus 1 equals negative 7 y plus 2. Then expand 3x minus 3 equals negative 7y minus 14. We want number at front of x is positive, so we move everything to the left side. 3x minus 7y becomes plus 7y. Minus 3 plus 14 is plus 11. Then it's done. So this is how we do it. We could just use a symmetric equation, then cross multiply, then find it. Okay? Then we are going to practice more on the normal. So this is a equation, example 2. Find the equation of the line with a normal to the direction of this 2, 3 and passes through a point. Write the equation in this form. So the normal will give us just a flip and a negative. So this is a rise, this is run, and we need to flip the rise run. So 3 and 2 flip and one of them negative. And R0 is 4, negative 1. So we use a symmetric again, x minus x0 over d1 equals y minus y0 over d2, then sub in x minus 4 over negative 3 equals y minus y0 is plus 1 over d2 is 2. Cross multiply and simplify. So expand. Why we expand? We want to collect the like terms. So 2x minus 8. With bracket, we don't know how to collect the like terms. Minus 3, then number at front of x is positive already, so we move everything to the left side. 2x plus 3y minus 8 plus 3 minus 5. Then it's done. So this is how we find the normal equation of the normal. Then continue one more practice. Just the practice on finding the normal, which is we didn't do it in our last lesson. So determine the vector equation is normal to this equation. This time is not given the direction vector, so we have to find the slope, then from the slope to find the normal. Okay, so 4x plus 3y minus 12 equals 0. So we are going to see, we isolate y, then we could find the slope. Okay, this is what we want to start. Isolate y, so move the x and the negative 12 to other side. So 3y equals minus 4x plus 12. Then bring the 3 to other side, do the opposite operation. Then we have y equals negative 4 over 3x plus 12. So our slope equals negative 4 over 3. So we could put the negative on the top, 3 at the bottom, then the perpendicular will be opposite flip, negative reciprocal. So negative becomes positive, reciprocal is 3 over 4. So rise is 3, run is 4. The direction vector will give us run is first, rise is after. So we have the D is 4, 3, R0 is a point on the line. Then we could write a symmetric equation again, because this is a vector equation, so we don't have to write a symmetric equation. So you need to know which one is our vector equation. So vector equation is in vector form. It's r equals r0 plus t times the direction vector. So r equals 7, negative 1 plus t times the direction vector is 4, 3. Don't forget, t belongs all real numbers. So these are the practice for the equation of a line in 2 dimensions. And the next one we are going to see in 3 dimensions. In 3 dimensions, what's the equation of a line? So equation of a line in 3 space of 3 dimensions, 3D, R3, or could write it in both. So r equals r0 plus t times m is same as before. The m is a direction vector, but this time you will have m, we write it as 3 numbers: x direction, y direction, z direction. So x, y, z, 3 direction. And r0 will give us x0, y0, and also z0, 3 direction. And from this one, based on the component vector, so r is our x, y, z. So we write x direction is x0 plus t times a, y equals y0 plus t times b, and z equals z0 plus t times c. So this is just expand in the component vector form. Then you will have the parametric equation of a line in 3 dimensions. And symmetric equation is just solve for t. X minus 0 divided by a, y minus y0 divided by b, z minus z0 divided by c. So all of them equals t. Then you have the symmetric equation of a line. And this time we don't have Cartesian equation. The standard form ax plus by plus c equals 0 may not work. So we don't have that form. We only have 3 forms for the equations of a line in 3 dimensions. Then after that, we are going to just practice on how to find the equation of a line in 3 dimensions. So find all the 3 form equations of a line that pass through a point. This is our R0. 2, negative 2, negative 8. And B is another point. We want to use AB 2 point to find the direction vector. Direction vector we could write it as AB or BA, it doesn't matter, but if we write it as AB, then the second letter O with second letter minus first letter with O. Then we sub in OB is 5, negative 2, negative 14, subtract 2, negative 2, negative 8. Then x direction, y direction, z direction, integer adding, subtracting. So x direction, 5 minus 2 is 3, negative 2 minus negative 2 is 0, negative 14 minus negative 8 is plus 8, is negative 6. Then we are going to just use these three forms, kind of like the equation of a line, the formula for that one. So R0 is 2, negative 2, negative 8 plus t times direction vector 3, 0, negative 6. This is our vector equation. Okay, and the next one, parametric equation. So it means we just, okay, t belongs to all real numbers, and this one is just the component vector, so x, y, z. So we are going to write each direction out. So for the x direction is 2 plus 3 times t, and the y direction is negative 2 times 0 times t is nothing. Y direction, z direction is negative 8 minus 6t, and indicate this is our parameter. Okay, t belongs all real numbers. This is symmetric, and after that, this is parametric and symmetric. Symmetric equation is just kind of we solve for t or x, subtract the x0, y minus y0, z minus z0, all over the direction vector. So 3, this is 0, so we need to get this one out, because divided by 0 is undefined, and z minus 8 plus 8 divided by negative 6. This is not defined, but we have to add in y equals negative 2. So y is not changing. It's parallel with the y-axis, the line. So this is a parametric, symmetric equation. Then this is our first part of the answers. Then we are going to do the next one. 2, for example, for find other 2 points, any other 2 points on the line. So we could just pick any of the equations. So vector equation may be good, so we could write t equals, and be careful, we don't want to have the same line. So t equals 0 give us the first line point, and t equals 1 give us a second point. So we don't want to use t equals 0 and 1. We want not 0 and 1. So t equals 2 we sub in. We are going to have the new vector will be 2 plus 3 times 2, then negative 2 plus 0 times 2, then negative 8 plus 2 times negative 6. Then do the calculation, we have 8 -2, then -20. So this is t equals 2, we could write. So t equals 0, t equals 1, we don't use these two. Then we could use t equals -1. So the point will be 2 minus 3, -2 plus 0, and -8 times -1 give us 6. So it's just a little bit easier for calculation to pick t equals -1. Just flip all the numbers to the opposite. And this is two other points. And example question 3, determine if the 2 points are on the line or not. So in order to prove it's on the line or not, we have to sub in this point to the equation and solve for t to see if the t exit or not. So P157, we want to check 1 equals 157, what's the t value? So 1 equals 2 plus 3t. 5 equals -2 doesn't work, so it's not on the line. So we don't have to go further to solve for the t. So because 5 is not equal to -2, so not on the line. And Q, we do the same thing. -4 is not equal to -2, so not on the line. Okay. And if we have another point, y is -2, then we have to solve for the t from these two equations to see if you have the same t. If you have the same t, then it is on the line. If you have different t, it means no t will satisfy that you give this x no z at the same time, then it's not on the line. Okay, so this is how you prove it's on the line or not. You just sub in to see the left side, right side equals or not. If equals, then it is on the line. Then we are going to practice one more. Okay, so this is an equation that is in the symmetric equation and converted backward. So this is in the parametric equation already, then it asks you to write it in vector equation. So in order to write it in vector equation, we need to find the r0 and the direction vector. Okay, so from this one we rewrite it -x over, because symmetric we have the denominator at the bottom. Okay, and the x should be positive, so we put the negative as the denominator. Then this one, no numbers subtract means 0, so no numbers subtract is 0. So we know that the number subtract is s, is our x0, y0, z0. So we have r0 equals 0 to 0. And our direction vector is our number at the denominator, so it's -1, 1, 1. We have r0, we have the direction vector. The vector equation for the line is 0 to 0 plus t times -1, 1, 1. T belongs all real numbers. So, and if you are confused, I will rewrite the symmetric equation here. So x minus x0 over a value equals y minus y0 over b value equals x minus z minus z0 and over c value z minus z0 over c, and r0 is our x0, y0, z0, and the direction vector is denominator a, b, c. So compare this with this equation, you will find out, okay, 0, x0, 2 is y0, 0 is z0, a, b, c is at the denominator, and be careful here. So we need to keep the number at front of x is 1x, okay? And if you have a number at front of, for example, we have 2, we need to flip it over, becomes 1 or 2 to keep the x as 1, okay? So this is what we have done for today. Today what we have covered is normal. Find the equation for normal. Normal is just rise, run, flip, and opposite. Flip, rise, run, then opposite. Flip, rise, run, then one number opposite. And also we have covered the 3 dimensions. We just add z direction there. So symmetric equation, just add z minus z0 over c. How to find the symmetric equation? Just solve for t. Move the number to other side, solve for t, then you will get a symmetric equation. Parametric equation is just component vector, x direction, y direction, z direction from the vector equation. Okay, so that is all for today's lesson. Thanks for watching.